Hey guys, today's video is going to be about graphing and coordinate planes and points and all that kind of stuff. So right now, let's say we have a one-dimensional point named Hauser. So the point of one dimension is that it can only really move in two ways. It can go forward and backwards, and those are the only directions it can go to, right? It can go this way and this way, but it can't go, front to back or stuff like that. So Hauser is really restricted to just going whoop and whoop. But one day, a three-dimensional being comes along and then just rocks his whole kind of understanding of the world. So this three-dimensional being draws another line going perpendicularly to Hauser's number line. So this is kind of crazy because now Hauser's like, oh my god, I can go this way and be right here, and I can also go that way and be right here, and he can really just, go wherever the heck he wants. And also, this stretches out infinitely that way, and infinitely up and down. So Hauser's thrilled, right? So let's just say that we want a way to describe the points on this graph, right? We want to quantify them. We want to assign a number to them. Well, first of all, we know that right here, we can assign kind of markers of where numbers can be right here, right? We could say this is 0.1, maybe this is 1 meter out, maybe this is 2, 3, 4, right? It's the positive number line. We could say, well, if that's a positive number line, we could also say that this is the negative number line right here. Just like, our regular one. So now we can describe how far left or right Hauser goes, right? Let's say he goes 27 units that way. We can say, okay, we can know where he is, right? He's way over there at 27. But let's also say he goes up and down, right? It's the same concept. You'd have to go 1 up, 2, 3. It's just another number line intersecting this one. So we're going up and down, right, on this number line. So side to side and up and down. But how can we know, like, let's say Hauser goes 4 out and then 4 up. Or 4 out and then 3 up. And we just, give someone the numbers 4 and 3. Well, we don't know if he went 3 out and 4 up or 4 out and 3 up or anything. So mathematicians decided to name these two different lines different things so that you could differentiate between them and call them different names. So this one going side to side is the x-axis, and this one going up and down is the y-axis. So x is side to side, y is up and down. And now that we have these names for these axes, we can describe the points that Hauser is at really easily. You can say, well, he went 2 on the x-axis and let's say, -2 on the y-axis. And the way you can kind of put this in a simple, easy to read form is you put 2 parentheses and you put the x value first, comma, and then the y value. So like, for example, this point would be parentheses, you go over 2 on the x value, so it's a 2, and then it's -2 on the y value, right? See how this point intersects with the -2 on the y-axis and then the +2 on the x? So then right here is going to be -2. So now that we have this system, we can do a whole bunch of stuff here. And, oh yeah, one more thing. So this is more helpful later on generally, but you call these 4 different little, quadrants that you have here, the boxes, this stuff right here, this area, this area, this area, this area. This one is called quadrant 1, and you write it in Roman numerals. This one's called quadrant 2, this one's quadrant 3, and this one is quadrant 4. And you really do this later on because it helps you kind of realize, like quadrant 1 is associated with the x being positive and the y being positive. Quadrant 2 is associated with the x being negative, right, all these negative values, but the y still being positive. So that's a lot more helpful later on. Anything else? Oh yes, and the origin is just the point right in the middle. It's just 0, 0. So it kind of looks like an owl. I'm just writing here, but this is 0, 0. See how it kind of looks like an owl? And that's basically the basics of the coordinate plane. So try to figure out how you can plot different points, and maybe even try exploring with different stuff like lines and things like that, and see how that would work.